Okay, so these quadratic inequalities are really tricky to solve. And remember, the key is to, first of all, pretend you just have something equaling 0 and try to factor it and get things together, and then make this sign chart and find out the regions where things are positive or where things are negative. All right, so let me try to illustrate this one more time by looking at another example. Suppose we wanted to find all the values for x for which 3x squared is always going to be less than minus 10 minus 13x. Okay, so there's a sort of a complicated looking inequality, and notice that the scary part is that I have an x squared in there, so this is not looking good. Well, what I'm going to do is treat this as though it were almost an equality. I want to get everything over to one side, have 0 on the other, and then hope that I can factor somehow. If I could factor somehow, then I'd be in sort of in hog heaven, because then I can sort of get pluses and minuses and figure things out. So I'll bring everything over to the left-hand side. So that 10, that minus 10, I'll add to this side as a plus 10. The minus 13x I'll bring over to this side. So what I would see after you bring all that over is 3x squared, then plus a 13x, because I bring that over to this side. And if I bring that minus 10 over, it'd be a plus 10. And that's all going to still be less than, but now there's nothing here, so I just have a 0 here now. Okay, so I have all this less than 0. So I want to find out all the values I could plug in here for x, which will make this number negative. That's the goal. Okay? Well, let's see. How should I proceed? Well, what I'm going to try to do is I'm going to try to factor this. So if I can factor this, I'd be in good shape, because I know if I have the product of two things and I know it's negative, then I know the signs of these have to be opposite, plus minus or minus plus. So let's see. First of all, the mission is to factor, so it's sort of a mission impossible here. So we have 3x and x, and now what I want to do is come up with a product that gives me 10, but when I combined everything, I get 13. So let's see how I would do that. It looks like a 5 and a 2 are going to work well. Is that true? Let's see. If I put a 5 in here, that's a 15. Well, that's not going to work too well here. So let's see. How about a 10 and a 1? Oh, a 10 and a 1 would probably work really well. But if I put the 10 here, that would give me a 30 plus 1. But if I put the 10 here, look what happens. Then here, I would see a 10x, and then I would see a plus 3x, and so I'd have a 13x. So when I FOIL this out, I actually see the middle term, and then this times that gives me the 10. So looking OK. All right, so now I've got this product of two things that result in something that's negative. So now how do I actually solve this? I'm going to make a sign chart. And so the first thing I have to find out are where on the sign chart does this thing actually vanish. So when does that equal 0? Well, let's take a look and see. So first of all, I set this equal to 0 and solve. So this could be 0 when 3x plus 10 equals 0. Well, that means that 3x equals negative 10. And if I divide by 3, that means that x equals minus 10 over 3. So minus 10 over 3 is one place where, in fact, this thing will be 0. The other place is when this is 0. But that's actually pretty easy to see. X plus 1 equals 0 when x is negative 1. So the other point is x equals negative 1. So now let me plot those 2 points on a number line. Now let me ask you a question. What's going to come first here? Is negative 1 bigger or smaller than negative 10 over 3? You might think negative 10 over 3 is bigger, but remember these are negative things. So minus 10 over 3 is way, way over, right? And negative 1 is actually pretty close to 0. So in fact, this will come first. This will be on the left, and this will be on the right. So when we actually plot this, here's a little plot. We're going to put, let's say, negative 1 way over here. So 0 would be way over here, you see. And then minus 10 over 3, which is like minus 3 and a third, is going to be over here. So these are the places, by the way, and I can sort of put in some little breakpoints here. These are the places where, in fact, this thing will equal 0. So I'll put a big 0 here to remind us that this thing actually will be 0 there. And I found that by factoring and setting this equal to 0 and that equal to 0. Now, in the regions that are left over, those are going to be either plus or minus. And I've got to find out what they are. What I'm searching for is where, in fact, the thing is negative. Right? I'm looking for where the thing is negative. So what do I do? Well, all I've got to do, the trick is to just pick any point in each of these intervals and just plug in and see what the sign is. And why does that work? Why does it not matter what point I pick? Well, let's think about it. Suppose I pick a point here, and it turns out I get something that's positive. Okay? If I get something that's positive here, Well, then could I get something that would be negative right over here? If this were negative here and positive here, there would have to be a place where it was 0. But I already found all the places where it's 0. So in fact, whatever happens at one point here, it has to happen all throughout. Because if it were to change, then I would have another 0 place. But I found all the zeros of these things. So in fact, this is the whole story. So this is either going to be positive and negative everywhere. This is either going to be positive or negative everywhere. This is going to be positive or negative everywhere. And all I've got to do, therefore, to find it is just pick a point. So in fact, let's pick a point here off on the right. You can pick any point as long as it's bigger than -1. How about 0? That's an easy point. So if you plug in 0 into here, let's see what the sign is. All I care about is the sign. Plug in 0 for x, that just goes away. This is a 10. But who cares about the 10? It's positive. So this is a positive. If I plug in 0 here, that's a 1, positive. Positive times a positive is positive. So this whole land here must be positive land, which means I'm not interested in it because I'm trying to find out where that's negative. So this doesn't look like an interesting place. What about in here? Well, now I need a point that's actually between -1 and -10/3. So you've got to think about this a little bit. How about -2? That's actually in between here. So we plug in -2. Remember, you could plug it back into here. That's fine. But that requires you to take 3 times -2 squared plus 13 times -2. Ooh, who can do that? But what I do is take the -2 and just plug it into here and look at what the sign is. -2 in here would be a -6 plus 10. Sign, positive. Okay, so this is positive. If I put a -2 in here, notice -2 plus 1 is actually negative. So this is a negative factor. This is a positive factor. When I multiply a positive by a negative, I get negative. So in fact, this whole land must be negative land. And then what must happen here? Well, you could pick a point like, let's say, -1,000, just to be dramatic. Doesn't make a difference. If I plug in -1,000 into here, what's the sign? Well, this would be -3,000 plus a 10. That's plainly negative. So that's negative. And if I put a -1,000 and add 1, that's still negative. So I have a negative multiplied by a negative, which gives me a positive. So to the left of this 0, I have all this positive land. So this function is positive in this region, it's negative in between these things, and it's positive here. I want to know, where is it negative? The answer is in between here. So the answer would be right in here. Now, here's the bonus question. Do I include these endpoints? Am I allowed to have this thing equal 0? The answer is no, because this is a strict inequality. There's no little underline there. So in fact, I don't want to include these points, so I have to put in these parentheses that just graze. So all the points strictly in between. This actually, some people actually think of this as the answer. That's the graphical answer. If you don't like that, you can write it in interval notation by just copying that. -10/3, comma -1, and you put the parentheses like that. Notice how I just copy that picture down. I always put the small value on the left and the big value on the right, even though they're negative. So anyway, so there's the answer to finding all the x's that satisfy that inequality. And you can check by picking points in here and plugging back in, seeing it's satisfied here, but nowhere else. So this is a graphical method in building a sign chart to actually solve these really difficult, challenging, but fun quadratic inequalities. Okay, I'll see you soon.